Hi everyone, welcome to this video lesson simplifying radicals. So in this lesson you will learn how to simplify radicals, not only square roots, cube roots, fourth roots, and up to fifth roots. Okay, so then the first one is square root of 9. So we know that square root of 9 is equal to 3 because 9 is the same as 3 times 3, which means we can take out the 3 and there's nothing left. So this is the answer to number 1. This one here, square root of 75, we can decompose 75 as 3 times 25, but then 25 is not prime because it's 5 times 5. And as you can see, we have two 5s, which means a 5 comes out, but that 3 stays inside of the radical because there's nothing we can do. We can take out for that one. We gotta have two of them, okay? Number 3, square root of, notice this one has a negative in front of it. So square root of 8, I'm decomposing that as 2 times 4, but 4 is not prime because 4 is 2 times 2. So then we have that the prime numbers that you multiply to get 8 is 2 times 2 times 2. But the point is we have a 2 coming out because we have two of them. So then keep the negative, the 2 comes out, and this 2 stays inside. So that's the simplest answer for that problem. Right. The next one. So the next problem is number 4. So for this one here, we just did that here, right? So that's 8, which is 2 times 2 times 2. But then notice this is the cube root, which means we need 3 of the same value or variable to be able to take one out. So we have 3 2's. Therefore, the cube root of 8 is equal to 2. Okay, next one, negative cube root of 54. 54 is the same as 9 times 6, but 9 is the same as 3 times 3, and 6 is the same as 3 times 2. Since we have 3 3's, we can take a 3 out, but let's not forget that we have a negative outside. So then this is negative 3 cube root of that 2 stays inside because there's only one of them. Okay, so that's the simplest radical form. All right, number 6, we have plus or minus. This is the fourth root, so that means we need 4 of the same number to be able to take one out. So 48, I decompose as 6 times 8, and 6 is the same as 3 times 2, and 8 is the same as 2 times 4, and 4 is the same as 2 times 2. So that means we need 4 to be able to take one out. So then from this problem, plus or minus, the 2 comes out, and then this is the fourth root of these 3 stays inside of the radical because there is only one of them. Okay, we need 4 to be able to take it out. All right, the next part is the one that is it gets interesting. So algebra 2 level, so this means you'll see variables in the radicals. If you have an odd amount or an odd power coming out of an even index, meaning square root, fourth root, sixth root, any even index, you might use absolute value if the power is odd. Okay, so then for this one here, we just did 48. 48 is this, so I'm just going to write this down as, let's see, 48 is the same as 3 times 2 times 2 times 2 times 2. And then we have x to the third, so times x times x times x. Since this is the square root, I need 2 of each to be able to take one out. So I have a pair of 2's here. I have another pair of 2's coming from these 2's, and that 3 stays inside. So far we have 2 times 2, and then we have a pair of x's, so times x, and then this 3 and that x stay inside, so this is what we have left. So when you multiply 2 times 2, that gives you 4x, but then notice the power of this x is 1, which means the power is it's odd, and the index is even because this is the square root, right? So then absolute value must be included inside of that, with x. So then what's left is inside of the radical is 3x. So this is the simplest answer for that problem. Okay, next one. So for this one here, I'm going to do this as 9 times 5, and this is as 3 times 3. 9 is 3 times 3, so then we have 2 3's, and this is the square root, so we need a pair to be able to take one out. So far we have a 6 outside, so 6 times 3, and then we have x times we have y to the fourth. So I'm going to do this for now, but then on the next problem, so I'm just going to, I'm explaining this one here, but then once I go over the others, I'm gonna go faster. So I can take out an x, so times x. I can also take out y times y. Okay, so y times y. So then the question is, what's left inside of the radical? Just the 5, right? So then we leave the 5 inside of the square root, and then multiply 6 times 3, which is 18. X has an odd power. The power is 1, so absolute value. Y times y is y squared, so that's an even power, so we don't have to worry about absolute value for y. and this is the simplest answer for that problem. Okay, number 3. For number 3, I'm going to notice that this is the fifth root, so I need 5 of the same number to be able to decompose, to be able to take one out. So I'm going to simplify this one. Let's start with, let's see. Let's do 2 times 243. Okay, then I'm going to decompose 243 as, let's say 3 times 81. And then 81 is 9 times 9, and 9 is the same as 3 times 3. So the prime numbers that we multiply together to get 486 are these here. So I have the fifth root, so that means I need 5. So I have 5 3s, which means I have a 3 coming out. So plus or minus, the 3 comes out. This is the fifth root, and what's left inside of the radical is this 2 that's by itself. Okay, so this is the simplest answer for that problem. Right, what about when you have variables? Same idea. So this is the fourth root. We need 4 to be able to take one out. Now I want you to think about this. How many times is 4 going to 13? 3 times, right? So then this will be x to the third. And then how many times is 4 going to 10? It goes twice. So then y to the second. And this is the fourth root. Hold on, not true. Let me fix this real quick. I'm making a silly mistake here because I need 4 to be able to take one out. So the x is correct. So x is to the third and y will be to the second, right? Because 13 divided by 4 is, you can take x times x times x, right? Because you have 3 sets of 4 x's and then 1 left. So then inside of the radical, we have an x left. And what about the y's? The y, we have 10, and 4 goes into 10 twice, so that's why this is y squared. So that means we have y squared left inside. Now, don't forget the index is 4, which means this is even. The power of x is odd, so then x must have absolute value around it. But the y is even power, so then we don't have to worry about absolute value around y. Only the power that is odd coming out of an even index. Okay. All right. So let's go to this one here. So 72. So for this one, 72 is the same as, we can do 2 times 36, and 36 is the same as 6 times 6, and 6 is the same as, we can do 3 times 2, right? So this is 2 times 3. So notice we have a pair of 2's and we have a pair of 3's. So this is and this is the cube root. So let me check this one real quick. Since it's the cube root, that means we need 3 of the same variable or number to be able to take one out. So I have a 2, this is a 2, this is 3, this is 2, and this is 3. So then I have this 2, and those 2 2's means I can take out a 2. So far I have 2 coming out. And then I have a to the third, and this is the cube root. So that means I can take out a. And then I have b to the fourth. I can also take out b. And then instead of the cube root, okay, this is the cube root of, we have 3 times 3, which is 9, right? So this is 9. We can't take out the 3 because we only have 2 of them. But then we have 1b left. And then this is an odd index. So that means we do not have to worry about absolute value. Only when the index is even and the power of what comes out is odd. Okay. All right. So number 6 for this one here. So I'm going to decompose 224 as, let's say 2 times 112, right? And then this is, let's see, 2 times 56. And 56 is the same as, we can do 2 times 28. And 28, this will be fun. So 4 times 7, and 4 is the same as 2 times 2. And I know you can barely see here, but I'm just writing this so small because I don't have a lot of space. So I have 5 2's, which means I can take out a 2. I have x to the 10th. I need 5 of them to be able to take one out. So then this is x to the second. I have y to the third. I need 5 of them to be able to take one out, so I can't take any y's. Okay, so notice inside of the radical we have this 7. So we have the fifth root of, let's see, so this is at 7, and then y to the third. So this is the simplest radical form for this problem, okay? All right, next one. Next one here, we have a -2, so 64, and this is the 6th root. So then this is 8 times 8. 8 is, we just did 8. 8 is the same as 2 times 2 times 2, right? So we have 2 times 2 times 2, and the same thing happens on this one. Okay, so we need 6 to be able to take 1 out, so we're taking out a 2. So then this is, we have a -2 outside, -2 times 2. We have x to the 11th, we need 6 to be able to take 1 out, so we have x coming out. We have y to the 18th, 18 divided by 6 is 3, so we have y to the 3rd. And then inside of the 6th root, we have left what? We have left x to the 5th. And is there anything else left inside? No, this is it, right? So then multiply -2 times 2, that's equal to -4 x y to the 3rd, 6th root of x to the 5th. Now notice, notice that both of these powers are odd, 1 and 3, and then the index is even, so that means x and y get absolute value around them. Okay, next example. So for this one, we need, this means we have x minus 3 times x minus 3. So when we take the square root of this, this is just equal to x minus 3. We have 2 of them, right? We can take 1 out. So, but notice this power is odd, so we must include absolute value around x minus 3. Okay, one last example on this video lesson. This is the cube root, which means we need sets of 3. So 3 goes into 10 3 times. So that means we can take out 3x plus 10 to the 3rd power, and then cube root of 3x plus 10 stays inside because we only have one of them left. So 3x plus 10. And again, the index is odd, therefore we do not need absolute value. So this is the answer to that problem. Okay, if you did not understand this lesson, don't forget I'll be in the classroom. You can ask me questions about this. Thank you for watching. Bye-bye.